big. Okay. So now, what I am going to do is give you, remember how for chapter 4, you had your orange sheet?
Now you got a pink
Okay,
sheet.
now you have a pink one
Can I get the pink
that
sheet?
you do not need to memorize. So that's the good news.
Thank you.
The bad news is that everything that you were supposed to memorize for chapter 4 needs to be memorized because you're not getting that one anymore. Okay? We're building up. The things you really have to memorize are that sine is the reciprocal of cosecant, tangent is the reciprocal of cotangent. That's what you really need to know. Okay? This chapter isn't going to have the 30, 60, 90 stuff in it. It actually does, but I'm leaving out that part. So you do not need to memorize what is on this sheet, except maybe, actually no, never mind, nothing on this sheet. You don't need to memorize any of it. I hope as we go through, you start learning some of it, because some of it's just used all the time. But here we go. 5-1. We are going to simplify trigonometric expressions. Okay, so what does that mean, Mrs. Ford? This looks terrifying. Sine cubed plus sine cosine squared. Now, let's get something straight from the beginning. When I'm missing the whole front row. When I say it out loud, like when I write it on the board, I say sine cubed plus sine cosine, but I never write a sine or a cosine, I never write any of them without an x attached. So even though I'm not saying it, I will always be writing it, okay? Make sure that you never write a sine or cosine or tangent or anything without attaching the x. Okay. Now, does anybody notice anything, a possibility of something I could do to simplify this?
Did you combine sides, the two sides together?
Okay, I can't combine them because it's just like polynomials, yet they have to be like terms. And this one is sine cubed, and this one is sine cosine squared. So they can't be combined. However, I am going to do something with that sign. They both have a sign, so I'm going to factor it out. So if I pull out a sign, what will I have left? Sine squared. And see, you guys, I'm sorry, this is so automatic for me, sometimes I forget. When we square or cube a sine or cosine or something, it goes here. This means sine x cubed. But we put the 3 there because if we wrote it this way, you see what the confusion might be? Yeah. Am I cubing the sine or am I cubing the x? So we put it here to tell us we're cubing the sine. If you want to write it this way with parentheses, that's fine, but you have to have the parentheses. Don't write it this way. This would be wrong. So this is 3 sines. Sine, sine, sine. So I'm factoring 1 out, and that's going to leave me with 2 left. Now what about here? What's left here? If I take out, I factor, regular factoring. If I take out the sine, what am I going to have left? Cosine squared. Okay? Ding, 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 ding. Look at your pink sheet. Somewhere on that pink sheet, you see a sine squared plus a cosine squared. Find it. it equals 1. Sine squared plus cosine squared equals 1. So every time we see a sine squared plus a cosine squared, we're going to change it into a 1. Just for your information, this is called the fundamental trigonometric identity. This is a big deal. It's on your sheet. So what's the answer to the question? Sine times 1 is just sine, right? When you multiply by 1, this is multiplication. So the answer to the problem is sine. What were you supposed to be doing? Simplifying. Did we simplify? We surely did. All right, let's try the next one. Secant plus 1, secant minus 1. Guys, I know this is baffling the first time through, and maybe even a second time through, but you'll get it. You just have to hang in, pay attention. Last period of the day on Friday. Hang in, pay attention, okay? So, you gotta do something with this. Who has a thought? FOIL, absolutely. All of the math that you've ever done in your life, you can do with trigonometry. So we're gonna FOIL. So that's gonna be secant times secant, will be secant squared, and remember we're writing it this way. This is secant squared. And then outsides, secant times -1. Insides, secant times +1. And then last minus 1. You might be thinking to yourself, well, this is not getting easier, this is getting, that's bigger, that's a mess. But what do you notice about it? Don't these cancel? So now we have secant squared minus 1. I want you to look on your pink sheet, right where you found this one, in that same little grouping of 3. The third one in that little grouping says this. By the way, this is your sheet to keep, so you can write on it. This is not my sheet. On test day, you'll get my sheet, but you can write on this one. You can take notes on this one. So, do you see how that identity off your reference sheet has a secant squared and a 1 in it? So you need to recognize that you can take what's written on your pink sheet and subtract 1 from both sides of it. This is what's written on the sheet. And if you did that, it would say tangent squared equals secant squared minus 1. Look at what's written on the pink sheet. And minus 1 from both sides. Wouldn't it say tangent squared equals secant squared minus 1? So look what you've got right here. What does this equal? Tangent squared. So now I have tangent squared divided by sine squared. Okay. Now, look at my little handwritten note up here. What do we know about tangent? It's sine over cosine. Okay, now, that's where I am, right there. That's tangent squared divided by sine squared. That's what I have, right there. But tangent squared is sine squared over cosine squared. Tangent is sine over cosine. Squared would be sine squared over cosine squared, sine cubed over cosine cubed, whatever. Times 1 over sine squared. Remember, dividing is the same as multiplying by the reciprocal. And what happens in this multiplication? Don't these cancel? And we're left with 1 over cosine squared. That gets you full credit. If you want a little bit of bonus, you'll remember that what's 1 over cosine? It's not on your sheet. What's 1 over cosine? Secant. This is secant squared. Now, I'd rather you not write that if you're not sure. This is good enough, 1 over cosine squared. That's a lot of work. And I get, kids, this is not my first rodeo. I know it's overwhelming. I know you're gonna be like, just cool it. We're gonna practice. We got pages and pages of practice. All right, number 3. First thing you gotta do is figure out how to start. So we're gonna look at problem number 3. And we're gonna try to figure out how to even begin. Now, you can only cross them out if it's a times. When we have a fraction minus a fraction, what do we have to do? Get a common denominator. We need a common denominator. That's what's happening here. We're subtracting fractions. No canceling, that's a minus. We only cancel when it's a times. Okay? So my common denominator will be both of these. 1 minus sine and cosine. That will be my common denominator. What does this fraction need? If this fraction is going to have this denominator, what does he need? He needs a cosine. So I'm going to give him a cosine. Which means that now on the top I have cosine squared, cosine times cosine, the new cosine times the original cosine. What does this one need, this second fraction? 1 minus sine. Now be really careful. You have negative sine times this new 1 minus sine you put in. So negative sine times 1 is negative sine. And negative sine times negative sine, positive sine squared. Bing, 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 bing. What do we have right here? That's 1. Cosine squared plus sine squared. Always, always, always makes 1. Always. So, those two make a 1. So I have 1 minus sine. That's a 1 minus sine. Over, oh my goodness gracious. Can't this whole shebang cancel with that?
Yes.
And what am I left with? 1 over cosine, which for that bonus, if you want, is secant. Isn't it amazing? Yeah. Okay. not gonna have a quiz. I mean, eventually all that'll happen. But we're gonna have 3 practice quizzes before we have a real quiz. It's gonna be okay. All right, calm down. All right, next, cotangent over cosecant. Would you agree with me that I could write that cotangent divided by cosecant?
Yes.
Now, what do I know about cotangent? It's 1 over it's the reciprocal of the tangent. Well, what does my pink sheet say about tangent? Tangent is sine over cosine. So what's cotangent? Cosine over sine. Divided by, what is cosecant? Reciprocal of what? Sine. So this is divided by 1 over sine. Cosecant is 1 over sine. Now again, you can write whatever you want on your reference sheet. So if you need to write some of this down, I'm okay with that. But the reference sheet you get for your quiz will be just like this. Okay? So when you practice, it's okay. All right, but what do we do when we have a fraction divided by a fraction? We turn it into a times and flip that one. Remember, Mrs. Field, keep, change, flip. So this is going to be sine over 1. Uh-oh, it's a multiplication problem. So I can cancel. Remember, we only cancel in a times situation. So what are we left with? On top we have cosine, on the bottom we have 1. So the answer to the problem is just cosine. All right, let's look at this. Oh, now this one I use theta as my variable. If you'd rather use x, that's fine. You can use whatever variable you want. Theta's great, x is fine, whatever you want. Now, this problem looks a lot like this one, would you agree? So let's kind of do it the same way. So what was the first thing I did with this? I made the division like a divided by. So cosecant divided by secant. Now, what did I do next? Changed the functions. So what is cosecant? 1 over sine. What is secant? 1 over cosine. Right? Now, how do I handle a fraction divided by a fraction? So 1 over sine times cosine over 1. Now nothing really cancels, so I'm just going to multiply. So what does that end up being? Cosine x over sine x. Who said that? Good job. That is cotangent. That is cotangent. Cosine over sine. Okay. All right. Rolling on. Number 6. around, okay? Alright, here we go. Cosine squared, 1 minus sine. Does anybody have a thought about this? Quickly, you haven't even thought yet. You can't shake your head no right off the bat. You gotta spend 30 seconds at least thinking about it.
One's positive and one's negative.
Okay, so we've got some positive and negative stuff going on. We also have a squared. Now, squareds, remember where you found that sine squared plus cosine squared over here?
Yup.
Can you tell me if sine squared plus cosine squared is 1? That's fact. Can you tell me what plane cosine squared would be? What would cosine squared all by itself equal?
Either 0 or 1.
0.5. 1 minus sine squared x.
Oh, what? Somebody said something that sounded like it might have been right.
1 over sine.
No. You guys, listen. If I had x plus y equals 1, and I told you to get y by itself, what would you do? You would subtract x, right? Isn't that true?
Yeah.
So if I want to get this guy by himself, what am I gonna do? Subtract sine squared? So won't cosine squared equal 1 minus sine squared?
Yes.
Think about it like it's a regular equation, guys. I'm gonna move this to the other side, so I'm gonna subtract it. Right? Now, not sure, but I think Ellie might be writing this down on her paper, on her pink sheet. That probably is not a bad idea. It's to remind you that you can always rearrange the things on the pink sheet. Yes, I have memorized sine squared plus cosine squared equals 1. I have a t-shirt that says that. For real. But that doesn't mean that it always looks like that. It can look like this. I can rearrange the terms. And it can look like that. So, if cosine squared is 1 minus sine squared, then I am going to put that in the numerator. 1 minus sine squared in the numerator. Now I know what some of you are thinking. Oh, we can cancel. No, we don't have any times, so we can't cancel. However, there is something very special about that numerator. We can't factor a sign out because we don't have one here.
So, does that mean the square is stuck?
Well, it has to do with the fact that it's squared. I want you to think again, think about your regular algebra.
Does it make it a plus?
If you had this, 1 minus m squared, could you factor that? Does that factor? How does that factor?
1 plus and 1 minus.
1 plus m and 1 minus m, because this is the difference of squares. You know, when that's a 9, it would be 3 plus and 3 minus, remember that? So what have I got here? I've got a 1 and I got a square. So that's gonna factor. Well, how is that gonna factor? 1, not plus. 1 minus sine x and one plus sine x. This is the difference of squares. And the difference of squares always factors the square root of this plus the square root of this, and the square root of this minus the square root of this. Well, what is so awesome and phenomenal about that?
They cancel.
Now I can cancel because I have times in my problem, and I can cancel the whole parentheses. So it boils down to just 1 plus sine. That's all that we have left after we do that. Now, that's a lot of steps. So let's recap real quickly. How did we start? We changed our cosine squared into, I erased it, but we changed it into 1 minus sine squared because of my pink sheet that says sine squared plus cosine squared is 1. And after we made that change, we noticed we had the difference of squares, so we factored and were able to cancel. So cool. So cool. I love doing these. Okay, what are we ready for? Number 7. Okay. I'm open for any suggestions. First of all, nothing cancels, nothing adds. So what am I gonna do? Does anybody have any thought at all?
Try and get something by itself.
Okay.
Sine.
Oh, wait, I heard something. What is tangent? Sine over cosine. So what if, I'll make that sine over 1 times sine over cosine plus cosine. Now, am I gonna cancel these cosines? No, because what's in between them? An addition, and what's it supposed to be? I mean, if I'm gonna cancel, it needs to be a times, right? So nothing cancels. But over here, this is a multiplication. Nothing cancels, but what's sine times sine? Sine squared. Over cosine. And I am still adding that to cosine over 1, plain cosine. Okay, now think about this, think about where you're at. You are not gonna cancel this because that's a plus. You have a fraction plus another fraction. We're gonna get a common denominator. How do we add fractions? Get a common denominator. See guys, your calculator's not gonna help you. We don't have any numbers, it's all letters. You gotta know that when you add fractions, you need a common denominator. So, this one's a cosine, this one's a 1. What is my common denominator going to be? Cosine? So this is good. This one's good. Sine squared is fine. This one needs a cosine. Cosine squared. Oh, beep, 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 beep. 1 over cosine, this is the third time we've run into that, that is secant. So here's the deal, folks. This is what we started with. And we worked our magic and ended up with that. Oh my. Too many heads down, eyes closed. Oh, you guys. I have a feeling in about 15 minutes you'll be full of energy.
Yeah, for sure.
All right, here we go. Big, long problem. Offer a suggestion. Think about all the things we've done.
One over cotangent.
Okay, so change them. I love that idea. Change them into sines and cosines. So what is cotangent? Well, it's 1 over tangent, but I want it in terms of sines and cosines.
No.
Guys, it's on your sheet. Tangent. Tangent is
Sine
sine
over
over
cosine.
cosine.
Sine over cosine.
So what's cotangent? Cosine over sine. Cosine over sine. Alright, so stop. Tan and cotan are reciprocals. On the sheet, I said tangent is sine over cosine. So cotangent will be the reciprocal of that. That's what tan and cotan are, they're reciprocals. Now, sine is sine. Plus, alright, what do I do with the tangent? Sine over cosine. That's on your sheet. If you missed that, you're just not paying attention. Times cosine over 1. We are, I don't know if you've noticed this or not, I haven't emphasized it. We don't change sines and cosines. They're like the fundamental building blocks. We change the other things into them so that we get matches and can either add or cancel or do whatever. So, these are 2 separate pieces of the problem. This right here is a multiplication. Would you agree with me?
Yes.
What happens? The signs cancel, and this piece of the problem just ends up being cosine over 1, which is just cosine.
Yep.
Now, this is the second piece of the problem.
Sine.
Those are gonna cancel, and I am just left with sine. Now, my beepers aren't going off.
This is tan.
No, that is nothing.
It's not?
No, they're not squared. The only time you can add them and get 1 is if they are squared. If they're not squared, then it's just cosine plus sine. That doesn't equal anything. That's just done. Done. All right, couple more. What is that? Okay, here we go. All right. Tell me if you notice anything about this problem. And I'm going to give you a hint. You should be looking right here where your sine squared plus cosine squared is in that little grouping. Those are called the Pythagorean identities. They're big. So, what? Yeah. 1 plus tangent squared is secant squared. Doesn't it say that?
Yeah.
So we're going to change this into secant squared. And it is times the cosine.
If you, does it matter if you just put it inside of the parentheses or not?
No, it can be or not be. It's up to you. If you're more comfortable inside, that is fine. Now tell me about secant. secant is reciprocal of cosine. So wouldn't this be 1 over cosine squared?
Yes.
Now this is a times, so I can cancel. Now I can't cancel everything because there's 2 of them down here, but that one will cancel with 1 of them, leaving me with 1 over cosine, which now for the 4th time today is secant.
Oh crap. So many secrets.
So many secants.
SEC. Like, for secret, we aim on our trash.
Stay with me,
I
folks.
be forgetting.
Butler all the way.
Stop. I want to finish this page, okay? We'll finish this page. When I see messes like this, I first of all think about this as a regular division problem. I know we don't do that a lot, but it helps me visualize, because I'm going to have fractions here. We're going to have fractions all the time, because what's tangent squared? Well, it's 1 over cotangent, but we never go that way, or very rarely go that way. We always want to be in sines and cosines. So this is sine squared over cosine squared divided by what's secant squared? 1 over cosine squared.
Okay.
Well, how do I divide fractions?
You better get multiplication.
So sine squared over cosine squared, keep this one, change it to a times, and make it cosine squared over 1. And the minute you change it to a times, now you can cancel. And the answer to the problem is sine squared. So this big ugly thing simplified down to sine squared. Now, this is a really important skill when you take your calculus class, because they're going to give you stuff like this and say, find the derivative of it, or find the integral of it. And if you can simplify it to just sine squared, that is so much easier to handle than something like this. That problem I can do in my head. If I have to find the derivative of it, you will be able to too. It's easy. This one, oh no. This one would be a pain in the butt. You can do it, but it would be a pain. All right, one more. I am not gonna say anything until I get a good idea from the crowd. So I want you to think about it for a second. I want you to look at the problem. Think about all the things we've done today. And does anything occur to you as to how to get started on the problem? Aiden?
The secant squared change to 1 plus tan squared.
Um,
Or no?
what, oh, first of all, Aiden, it would not be wrong. Secant squared is 1 plus tangent squared all the time, forever and ever. So if that's what you want to do, you absolutely can do it. Because I have like lots of experience with this, I know that isn't the easiest thing to do, but it is not wrong. And you could do that and then move on like that. Great idea. Change secant squared into 1 plus tangent squared. Anybody see something else? Izzy?
Isn't secant cosine?
1 over cosine? So you could definitely change that into 1 over cosine squared. Absolutely, it's correct. You could do it. I don't think it's the easiest thing to do. In a minute, I might be doing that, but it's not the It's not the best way to start, I don't think, Noah?
Sine over 1.
Okay, that's not wrong, that's not wrong.
Cancel out the signs.
I can't cancel out the signs.
They're not
No multiply.
They're not multiplied, and this one is hooked onto this. This was where we started though today. I can't cancel them out, but what can I do? Since they both have a sign,
Factor.
I can factor out the sine squared. And what will that leave me with? If I take out a sine squared, I'll have what here? Secant squared.
Negative sign.
And minus 1. Now, Aiden, I'm going back to 1 plus tangent squared is secant squared. So what is secant squared minus 1? Rearrange this. If you move this to the other side, wouldn't that be, isn't this tan squared? So we have sine squared times tangent squared. Right? Well, what's tangent squared? This is sine squared over 1. See how I'm using all your ideas? I'm using all your ideas. What's tangent squared? Sine squared over cosine squared? Oh, shoot. Can't cancel, so I guess I'll just multiply. What's sine squared times sine squared? Sine to the 4th over cosine squared. Problem done. Finished. Finished. That's it for today. Pack up. I know you guys think that I'm